Welcome back, everyone. Today, we're diving deep into a Cambridge Mathematics past paper topic that honestly makes or breaks your final grade. We are looking directly at syllabus code 0580, specifically focusing on the infamous functions questions. Now, look, I see the warning signs all the time. Let me tell you about two types of students I see every single year. First, we've got Alex. Alex overloads with raw mathematics facts. Alex just brain dumps every single algebra rule they've ever memorized onto the page with absolutely zero analysis of what the question actually wants. It's a mess of numbers, and the examiner literally cannot follow the logic. Then we have Sam. Sam is constantly watching the clock, panics, rushes through the paper, and completely misses the command word requirements. They'll do the math right, but answer the wrong question entirely. Both of these approaches, they sink grades. You'll see their flawed answers covered in red pen marks simply because they didn't have a strategy. Today, we are completely changing how you look at algebra. No more random letters and numbers. I want you to imagine a factory. Think of a mathematical function as a highly predictable machine on a factory floor. You drop a raw material in, the machine does a specific action, and a finished product pops out. It is really that simple. We're going to read the warning signs, avoid those common pitfalls, and rack up maximum marks. To get you operating this factory like an absolute pro, and to stop you from making Alex and Sam's mistakes, we have a precise 4-part agenda today. 1. The basic machine. 2. Running in reverse. 3. The assembly line. And 4. Testing your knowledge. Along the way, I'm going to be breaking down the specific Cambridge assessment objectives and showing you exactly how top students structure their answers to guarantee they don't drop those easy points. Let's get right into it. Okay, let's dive into this. Section 1. The basic machine. This is where we start looking at command words. When a Cambridge exam says evaluate, what are they actually asking you to do? Sam usually skips right past that word and just starts multiplying things. Don't be like Sam. Evaluating a function just means you are taking a specific number and dropping it into our mathematical machine. That's it. Let's look at the notation. In algebra, an expression like 4x minus 9, where the variable is x, is officially called a function of x. Its final numerical value entirely depends on whatever value we decide to give to x. Mathematicians write this cleanly using an italicized f followed by an x in parentheses. We read this out loud as f of x. So f of x equals 4x minus 9. Now, to make sure you get 4 marks here, we need to introduce the Peel framework. You might know Peel from English class, but it works wonders in math to keep your answers structured. Point, evidence, explanation, link. Your point is identifying the correct function the question is asking for. The x in the parentheses, that's the input slot on our machine. The 4x minus 9, that's the instruction manual telling the machine what to do. Let's see the Peel framework in action to see exactly how predictable this machine is. We have a new machine, f of x equals 3x minus 5. The instructions are, multiply the input by 3, then subtract 5. Look at the first row. If our input, x, is 2, we write f of 2. This right here is your evidence. You are showing the examiner you know exactly what goes into the machine. We substitute the 2 where the x was. For your explanation, you show the working. 3 times 2 is 6 minus 5. And finally, your link to the final answer. It gives us an output of 1. Drop in a 0. 3 times 0 is 0, minus 5 is negative 5. Drop in a negative 2. 3 times negative 2 is negative 6, minus 5 gives us negative 11. Predictable, reliable, and perfectly consistent. By showing every step, from the substitution to the final output, you are securing every single available mark. Before we continue, subscribe to our YouTube channel Ace the Exams at acexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Right, let's keep the momentum going. Section 2, running in reverse. This is the exact spot where a lot of students start to panic. But if you have a system, it's actually a breeze. What happens if we find a finished product at the bottom of the machine and we need to reverse engineer it to figure out the original raw material? We have to put our machine into reverse gear. The command word for this on your 0580 paper is usually find the inverse. Visually, the notation changes to signify this, and this is where Alex loses marks by overloading on facts without analyzing. On the left, we have our standard forward-moving machine, f of x. On the right, you'll see f with a little negative 1 superscript, followed by the x in parentheses. Now listen closely, because this is a massive trap. That negative 1 is not an exponent. You absolutely are not multiplying anything by negative 1, and you aren't flipping it into a fraction like you do in index laws. In the specific language of functions, f inverse of x simply means we are completely undoing the machine's effects. It's the exact mathematical reverse. Do not let the examiner trick you with that notation. To actually find the algebraic formula for this reverse machine, you need a strategy. We call this the Mathematics Success Blueprint. It's a highly specific, foolproof, three-step method that guarantees you hit all your assessment objectives. Step 1. You take your original equation and rewrite it, replacing the formal f of x notation with a simple letter y. Step 2, and this is the absolute magic step, you literally swap the positions of the x and the y in the equation. You interchange them. Step 3, you use your standard algebra skills to rearrange that new equation to make y the subject again. If you write these 3 steps out clearly on your exam paper, you are providing the perfect evidence and explanation that examiners are desperately looking for. Let's move to a live example and see how this builds. We're going to transform a typical flawed answer into a perfect score right now. Imagine giving yourself 60 seconds for this rewrite attempt. Let's say our original function is f of x equals x plus 2. Alex would try to guess this in his head and just write an answer, getting 0 marks for working. Instead, follow the blueprint. Step 1, we rewrite it as y equals x plus 2. Step 2, we swap the variables, so it seamlessly becomes x equals y plus 2. Step 3, we solve for y. To get y completely by itself, we have to subtract 2 from both sides, leaving us with y equals x minus 2. We've done it. Our inverse function, f inverse of x, is x minus 2. Look at those red pen marks literally transforming to green check marks. And logically, it makes total sense, doesn't it? If the forward machine adds 2, the reverse machine absolutely must subtract 2. Brilliant! Let's push forward to section 3, the assembly line. Now that we have single machines working forward and backward, it is time to upgrade our factory floor. This is where we hit the higher tier questions. Think of composite functions as connecting 2 machines together with a conveyor belt. The output from the very first machine drops immediately into the input slot of the second machine. The notation for this is written as fg of x. Notice there is no space or symbol between the f and the g. Now, the single most important role here, and the one that trips up even the smartest candidates, is the direction you work in. You do not read this left to right like a book. You must work from the inside out, or right to left. For fg of x, the entire g of x expression is picked up and dropped completely inside the f function. The x goes into the g machine first. If you decode that notation properly, you've already won half the battle. So the crucial point is how we substitute this algebraically without making a mess. We have 2 machines here. f of x adds 2 and g of x adds 3. We want to find the formula for the assembly line fg of x. Step 1, we take the entire formula for g, which is x plus 3, and we confidently use it as our input for f. That's your evidence. Step 2, we write out the f function, but wherever we see an x, we plug in our new input, x plus 3. So the f machine says, take the input and add 2. Our input is x plus 3, so we get x plus 3 plus 2. Step 3, we simplify for the link. 3 plus 2 is 5. Our final composite function is x plus 5. We've merged 2 separate machines into one sleek, efficient unit. And by showing that full breakdown, you secure top marks. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get into Section 4, Testing Your Knowledge. This is our interactive workshop. You have the theory, you have the methods, and you've seen the factory in action. Now it is time for the true test. I want you to imagine a 60-second timer on your screen right now. Here is your first data scan challenge, pulled straight from actual exam-style sources. We have function f, which doubles the input and adds 3. We have function g, which just doubles the input. The command asks, what is the numerical value of fg of 3? I want you to calculate the steps here. Find the flaw in how most people do this. Most people calculate f of 3 first because they read left to right. Don't do that. First, you need to find the unified composite function, fg of x, working right to left. Once you have that new algebraic expression, you will substitute the number 3 into it. Take a second to mentally lock in your method. And the answer is 15. Did you nail it? Let's break down the exact examiner commentary on why this works. To find fg of x, we put the entire g function inside the f function. The f function is 2 times the input plus 3. So we replace that input slot with the g function, which is 2x. That gives us 2 times 2x plus 3. Simplifying that, our composite machine is 4x plus 3. Now we evaluate it by dropping in our number. 4 times 3 is 12. 12 plus 3 equals 15. Brilliant work if you followed those exact steps. You effectively utilize the Peel framework by showing the correct composite point, the substitution evidence, the simplification explanation, and the final numeric link. Let's try one more. We're going into speed writing mode now. Imagine a 30-second timer to write one perfect full-mark paragraph for a slightly more complex problem. We have a function f of x equals x minus 3 all divided by 3. The question asks us to evaluate f inverse of 2. Notice that command word right there, decode it. We are not dropping the 2 into the standard machine. The -1 means we are dropping it into the reverse machine. The correct answer is 9. How did we get there so fast? By rigorously applying our golden 3-step rulebook. Step 1, rewrite as y equals x minus 3 over 3. Step 2, swap the variables to get x equals y minus 3 over 3. Step 3, multiply both sides by 3 to get 3x equals y minus 3, and then add 3 to get y completely by itself. Our inverse function is 3x plus 3. That's the heavy lifting done. Finally, we evaluate by substituting the number 2 into our new reverse machine. 3 times 2 is 6, 6 plus 3 is 9. Full marks achieved, no panic, no rushing, just pure strategy. What an absolutely incredibly productive session. Look at your progress bar hitting 100% right now. Let's recap the complete mathematics answering system we used today. 3 rules that guarantee top marks. Number 1, command word decoding. You must know if you are evaluating, finding an inverse, or building a composite. Number 2, the Peel framework application. Point, evidence, explanation, link. Show every substitution and every algebraic move. Number 3, the time management matrix. Don't rush like Sam, but don't get bogged down writing out irrelevant facts like Alex. Apply the blueprint efficiently. You've mastered 3 distinct ways to manipulate mathematical machines today. You can evaluate a standard function, you can run the machine in reverse, and you can build a mathematical assembly line. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Before we go, I want to leave you with one final provocative thought to ponder before your next exam. We know we can run different functions together on an assembly line, like f and g. But what exactly happens if you build an assembly line using a function and its exact inverse? What is the actual mathematical result of f inverse of f of x? Think about the factory floor for a second. If one machine adds 5 and the machine immediately next to it subtracts 5, what happens to your raw material? I highly encourage you to test this algebraically on a piece of scratch paper right now. The result is beautiful in its simplicity, and it's a massive shortcut if it pops up on a paper. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing those past papers, and I will see you next time.